Good morning. As per the theme of the conference, I will be speaking about monetizing your spatial data. And if I can see the first slide, thank you. Certain technologies, such as point clouds and mobile devices, are well used in discrete segments of the infrastructure development process. However, information mobility adds value throughout the life cycle of infrastructure by managing the data produced and making it available in all phases of the project. Data is enhanced and managed as opposed to used and discarded, improving the return on investment on all technologies. Point cloud technology has become the de facto method of acquiring existing conditions for a new development or an enhancement to existing infrastructure. But the use of point clouds does not stop at documenting existing conditions. Hybrid workflows, presentation materials, development of detailed terrain models all extend the use of point clouds into the infrastructure lifecycle. Similarly, mobile technology is commonplace in the consumer realm, from smartphones to tablet computers. Such acceptance is driving requirements for access to infrastructure data in the field. How can large internal systems and databases be leveraged for use on smaller mobile devices operated by users not familiar with spatial concepts? So today I will concentrate on those two technologies, point clouds and mobile devices, to show how these technologies fit within the infrastructure lifecycle and the benefits received. Bentley is involved in these infrastructure segments, and geospatial technology is used across them. As we have said last year at the Geospatial World Forum, the G of geospatial is everywhere. For Bentley, geospatial is not just an industry, but rather a layer of technology that is increasingly prevalent in our offerings, from utilities to communications, from engineering, information management, and ultimately operations phase with products like EXO for operations and bridging into the enterprise. As a private company, we do not have to make our financials available. However, we do that as we find it important that our users know how we spend their money. In 2012, Bentley grew to $550 million, and of those revenues, we typically invest 25% back into research and development, and that reached a record high of $200 million of investments in 2012. Advancing GIS for infrastructure. Bentley's geospatial technology is applied to the commercial world of planning, design, construction, and operating infrastructure across the globe, where it is municipally owned or investor-owned, or government-owned or investor-owned. We have always been about delivering business value through our software to support the owner-operators and the engineering firms who build and operate the world's infrastructure. Bentley's never believed in the need of a division between engineers and GIS. Bentley's geospatial technology is made available seamlessly within the industry-specific applications that engineers use to design and operate infrastructure, from roads, rail, communication networks to utility networks and more. Working with existing geospatial data repositories saves time and costs. Data does not need to be recreated or transformed. Bentley believes that open, non-proprietary data delivers better returns. To this end, Bentley supports industry standards, both those that are published, such as the OGC standards, WMS, WFS, etc., and the de facto standards, such as Oracle Spatial, SQL Server Spatial, Google Maps, and what have you. Another way of monetizing geospatial technology is to make it mobile across extended workflows, from planning to operations, and literally mobile too for non-GIS specialists, as I will come to show you. So let's now look at the role of information mobility across the infrastructure lifecycle and how this improves the return on investment on infrastructure projects and the software deployed to support them in the various phases of the project. What needs to happen is that geospatial information needs to be captured, enhanced, and validated. This obviously puts forward requirements between systems, people work and location of work and managed during the various phases of the reuse. The end result is a reduction in total cost of operation for the entire organization and its ecosystem of external parties that collaborate on the same project. This is your data at work, improving the effectiveness of your organization and the external world that you may need to communicate and exchange your data with. Bentley has been promoting mobile technology for many years. Field users, however, were not ready for handheld devices a few years ago. But with the consumerization of tablet devices, users of all types are now familiar with the technology and are starting to demand it. So let's face it, everyone has a smart device, or maybe two, in their possession, and it doesn't require an IT or a GIS degree anymore to operate it and to be spatially aware. The consumer can do it. The data collection has become more widely spread with not only lower cost and better performing high-end scanners, but also augmented with cameras or even phone imagery. Or live data is fed back by sensors in the field. These sensors can allow you to compare as-designed structures with the as-built situation in later time and perhaps of an infrastructure under stress. And this consumerization will accelerate information mobility as users demand to be able to view industrial data on their consumer devices. How do we make that happen? So let's talk about a few technologies that Bentley has in the geospatial arena. We have three major areas of innovation, two of which are already commercialized and available to our users, and a third which is ongoing research and development. The first is our innovation in processing and managing point clouds. The second involves making geospatial information available in the field to non-GIS technicians on tablet devices. And the third is about spatially enabling our operational asset information platform to support workflows that are not well supported by vanilla GIS. So with regards to point clouds, after the acquisition of Point Tools by Bentley in 2011, we made point cloud data a native data element without our microstation environment and provide an API to all the above application layers to take advantage of point clouds and allow point cloud data storage on our project-wide servers for selective downloading, delta file transfer, and smart caching to allow store once and use many, or store once and use everywhere, or store once and only use the part that you need. So we're showing I need to see if the AVI works, but I think it does. We're showing here an example of a point cloud from which we clip a section, and then based on the point cloud data, we model the section of the bridge and the columns that you see in the model. The extrusion of solid models and columns is happening here in a hybrid model between CAD and point cloud data. Collecting LiDAR information with its massive amounts, is the AVI running? With the massive amounts of points and then draping it over a digital terrain model, as you can see here, and rotating and panning in real time is another example of using high volume raster data in a 3D hybrid environment. Last example I have is a point cloud of an existing railroad track which has been overlaid with survey data. You see the animation, along the path of the track. The point cloud and survey data is once again in a hybrid model, which subsequently allows you to do, for instance, placement of new electrical signs and visualized with or without the point cloud data in its environment. So here's an example of augmented reality This example is, and unfortunately I think the AVI does not work on this. We've been trying that to make that work upstairs. What it would show in the AVI, which we can show later on in the booth, is the ability to merge the augmented reality of where you stand in the field with the engineering information or the GIS information that sits in your GIS database and the attribute data that belongs to it. This attribute data may come fed out of your GIS system or even out of your ERP system. So this way you can see that rather than having a lot of collected data that goes nowhere and that becomes dead-end information, now becomes reusable data that is deployed throughout the information lifecycle of the assets. So a product that we're introducing this year is Bentley Mobile Mapping. The product is first going to be brought out on Android. And you see the usual look and feel or pinch and zoom functionality and feature displaying dependent on the zoom level that you zoom in on. Properties of the assets are passed on down to the device and can be used in the field environment. This will allow field workers to be self-sufficient in the field without drawings, but also without a laptop or a PC, and instead be mobile on their Android device and be geolocated as and where they stand. We can show the Android application at the booth later today. And here's an example of what we call a virtual excavation. The augmented reality capabilities support concepts that allow a user to create a virtual excavation which can be moved and expanded in order to see the underground utilities in the context of the actual above the ground buildings. In cases where no utility model exists, we can also use this prototype to display the results of ground penetrating radar in 3D. This example, by the way, runs on the iPad platform. Our Apple apps can be downloaded for free from iTunes, from the iTunes store, and you'll find, if you go to iTunes today under the Bentley header, 5 applications that are there today. We also have a development and a programming interface environment available to allow end users, as well as third parties, to develop their own apps. We think there's going to be thousands of apps, and we surely are not the only ones who have bright ideas to invent those. So what are some of the examples of field-based tasks? So here we show a few examples that span from design, constructions, all the way into operations. And when you think about the process a little more, there is a high-level workflow that is usually quite common, which includes to prepare and collate the data, to package and distribute data, carry out your field task. This might, for instance, be inspection. Return the finding in your data package and then process the field task findings back to the home system. We've taken on the challenge of migrating engineering data into mobile workflows by creating a new server product called Dynamic Composition Server. This dynamic composition enables you to transform data for your mobile device access. This enables you to transform major engineering formats into industry standards like 3D PDF or Bentley's iModels, which are optimized for mobile devices. The Composition Hub will also automate the packaging of fieldwork packages based on your project rules. As we say, all magic happens on the server. And there will be thousands of apps written by people, and we encourage hence the development community to pick up the opportunity to create what makes sense to your own organization. We will provide the information management and publishing services to allow your data to become mobile as a result. So success can only be obtained by supporting our users in their endeavors. The example that is shown here is the Crossrail project, which is a $24 billion project for 90 kilometers of rail, which is predominantly going in a twin-board tunnel underneath London's city centre. It includes the upgrade of 18 train stations and the integration of the existing metro system, and that makes this the biggest and the most complex project currently on the globe. And I think the complexity in the image here speaks for itself. Crossrail uses information mobility to store all asset information in open and accessible systems. These systems feed information from design and construction through to operations and maintenance as they move along. With the UK government and a British standard 1192, BS 1192 has been established to define a building information model that standardizes information exchange and enhancements amongst the hundreds of engineering firms that work on this bespoke project at the same time. And everyone needs to be current with their data. So with that, our journey from spatial information modeling through management of the data and the monetization of the mobile environment, we hope to have given you an insight in the return on investment on your infrastructure information. Thank you.